In this example, we are going to evaluate expressions involving rational exponents. If the expression is not a real number, we will explain why this is so. In part A, we have in parentheses -8 raised to the 1/3 power. If it helps us, we can first rewrite this as a radical statement. So something raised to the 1/3 power means we're dealing with the third root of that. So -8 to the 1/3 really means the third root of -8. And to evaluate that, I need to ask myself what multiplied by itself 3 times would give me -8, and the answer is -2. In part B, -16 in parentheses to the 1/4 power would be rewritten as the fourth root of -16. Again, I ask myself what real number multiplied by itself 4 times would give me -16, and the answer is there is no real number that could do this. So this is not a real number. In part C, we have 25 to the -1/2. Now there are two parts to this. There's both a fractional exponent and a negative exponent. The first thing I would do is deal with the fact that the exponent is negative. A negative exponent means we need 1 over whatever the statement is. We need the reciprocal. So I would first rewrite this as 1 over 25 to the +1/2. And now that the negative has been removed from the radical, I would continue going with what we've done previously. I would rewrite that 1/2 exponent as a square root. So I'd have 1 over the square root of 25. Knowing that the square root of 25 is 5, this becomes 1/5. And now in part D, we have -100 to the 1/2. It is important to remember that an exponent only applies to what it is immediately next to or what it is touching. The exponent is not next to that negative, so this really means we have a -1 times 100 to the 1/2. If we had wanted that negative to be captured inside of the 1/2 exponent, we would have needed something like part B, where the -100 was in parentheses. But since it's not, the negative and the 1/2 exponent do not interact. At this point, we can rewrite that 100 to the 1/2 as a square root. So this becomes -1 times the square root of 100. The square root of 100 is 10, and -1 times 10 is -10. Often, when we evaluate expressions involving rational exponents, a good trick is to first rewrite that as a radical statement, and then evaluate the radical version of that statement.